Hey, let's talk about one of the hottest open source technologies in the CI/CD space, Tekton. To discuss Tekton or any other CI/CD system, we need to recap the concept of a job execution engine. I made a video about this topic before and I will put the link to it in the description below. In short, you can look at the job execution engine as a system that consists of three elements: a job server, a job scheduler, and a job executor. Any CI/CD system is a job execution engine. If you look at Jenkins, the Jenkins server is a job scheduler, job server is any server that has a Jenkins agent installed, and Jenkins agents are job executors. Kubernetes itself can be considered a job execution system. It has a scheduler that takes care of placing pods on the nodes, and we can consider pods a job executor and the node where the pod is running a job server. Naturally, there is a way to go for a simple job execution engine to become a fully featured CI/CD system. Normally, a number of primitives are added on top of the aforementioned basic elements. For example, every modern CI/CD system has a concept of a pipeline, a series of jobs often called build stages that perform different tasks like building the software, testing, and finally releasing it. Another thing that CI/CD systems have are, quite often, a nice UI and many integrations with different tools. It's hard to imagine a CI/CD system that doesn't integrate nicely with the source code management system, like GitHub or Bitbucket. In general, CI/CD system has many different layers on top of the simple job execution, and it makes it easy to build and deploy your software. A proper system like this abstracts the lower level details away from you and lets you focus on building the continuous deployment pipelines in some form of a system specific code like GitLab CI YAML or Jenkins file. Now let's see how Tekton fits into this picture. Tekton is a Kubernetes native CI/CD system. This means that instead of having its own scheduler and primitives, it leverages Kubernetes as much as it can, and it requires a Kubernetes cluster to be deployed. There is no Tekton without Kubernetes. It is impossible to talk about Tekton or understand what Tekton is without knowing Kubernetes. From this moment, I will have to use Kubernetes specific terminology. If the words like pods, custom resources, controllers, and others are foreign to you, then you can already imagine one of the specifics of Tekton. It's so Kubernetes dependent that without Kubernetes knowledge, you can't even make sense of it. The primitives that Tekton adds on top of the simple job execution are implemented as a Kubernetes custom resource definitions. The job is implemented as a task custom resource, and to run the task, you need to create a task run. To chain multiple tasks together, you need to create a pipeline, another custom resource. And to run the pipeline, you create the pipeline run. Those tasks and pipelines can be fed with different inputs in form of params, config maps, secrets, volumes, and so on. Those are the basics of Tekton. The usage of CRDs allows Tekton tasks and pipelines to be easily reusable. You can define an organization's global set of tasks to perform common operations and construct pipelines out of these tasks. And you can even have a set of common pipelines applicable to every application of the same type. Inside tasks, there is nothing but pods. Every task runs as a pod from a container image with some steps performed inside the container. You can provide a specification for these pods and do anything that you would normally do with Kubernetes pods. So, how do you create new task runs and pipeline runs? One way to do this is to use the Tekton CLI or kubectl. But that, of course, is not ideal, as you need a human to do that. Another way is to use one more object from Tekton, Event Listener. Event Listener is a special deployment with a service that listens for HTTP requests and processes them by using triggers, which are in turn depend on two more objects: the trigger binding object, which maps the received payload to Tekton params, and the trigger template, which gets those params and generates a new pipeline run. Naturally, all of those objects are a lot of YAMLs to automate. Just like with tasks and pipelines, you can create a set of common trigger templates and trigger bindings. Let's draw the full picture of a simple pipeline. Imagine we simply want to lint some YAML files on a new pull request in a GitHub repository. Don't worry too much about the details of each of the components. If you start looking inside those boxes, you will get crazy. First, we need 3 task definitions: to clone the repo, to lint the files in the repo and to report the result of the build back to GitHub. We also need a secret with Git credentials, a persistent volume so that lint YAML task can access the repository cloned in the git clone task, and a service account so that Tekton can access the secret internally. But let's omit those details from the picture. We need to change these tasks in a pipeline. To trigger the pipeline, we need an event listener. For each event listener, Tekton will create a new service and deployment, and we need to expose this deployment with an ingress or an OpenShift route. As mentioned before, listener needs to map requests to trigger binding and trigger template. Keep in mind that you will probably need multiple trigger bindings and trigger templates, as well as something called an interceptor, at least one per event type that you want to process. Finally, the pipeline run will be created and your build is running. To build such a pipeline, we need to create objects of 6 different types, including multiple tasks. In addition, this would also require creating secrets to connect to GitHub and persistent volumes to share the state between the tasks inside the pipeline. Once we go beyond the single pipeline, we end up with a huge amount of such objects. We would need to properly plan how we want to organize and deploy tasks and pipelines, which images we use inside the tasks, how we maintain event bindings, and so on. We would have to combine the knowledge of Kubernetes with the knowledge of Tekton-specific objects to build our CI/CD system. And this is the most important thing to know about Tekton. It's not a fully featured, ready-to-use CI/CD system like GitLab CI or Drone CI or many other systems. Instead, Tekton is a already very powerful set of CI/CD primitives that you can use to build your own CI/CD system or even general-purpose task automation system. It's the same difference as between Kubernetes itself and a platform-as-a-service solution. Kubernetes gives you all the building blocks to create your own platform as a service, but Kubernetes itself is nowhere close to being this kind of platform out of the box. Having such a flexible set of building blocks that Tekton provides lets you build truly flexible, powerful and tailored to your organization's CI/CD systems that you can easily move between different Kubernetes clusters by simply reapplying the resource definitions. But you need to remember that it's a lot of work and you might be better off by using an existing ready-to-use solution. That being said, I personally love Tekton, exactly for this approach of giving you the building blocks. It might not be useful for smaller setups, but it can bring amazing benefits for mid to large organizations. If you want to learn about Tekton in details and how to use it, please tell in the comments below. If your company wants to migrate to Tekton or introduce it from scratch, MKDev consultancy team can help you with that. Contact us via the email in the description below. That's it for this video. If you liked it, don't forget to press the like button and subscribe to our channel. Thanks for watching.